Okay. So, good morning. In my first lecture, I had discussed about the metallic nanoparticle. Today, I am going to discuss one of the important aspects of this chapter, that is called the semiconductor nanoparticles. Sometimes, actually, it is referred as quantum dots because the size of these semiconductor nanoparticles range is very low, that is 1 to 10 nanometer. It is a general perception. And second important point is that you all know that the size of this nanoparticle based on different aspects, like I have already discussed about the quantum confinement and the distance between the valence band and conduction band, and you know the band gap and other things, and the band energy is also very important. And if you see the literature, there are thousands of research papers related to this semiconductor nanoparticles, because their size is as low as it is less than that Bohr exciton radius, and therefore as per the requirement you can tune all those semiconductor nanoparticles, and it can be used in all fields of the science, whether it is a medical science or even in sensor, catalysis, optoelectronics, everywhere. So what I have done, because it is very broad subject, and if you ask me the classification of the semiconductor nanoparticles, it is very difficult for me, because it is related to some non-oxide type of the nanoparticles, some are oxide type of the nanoparticles, and in spite of that I have tried to classify, and in this short lecture, as per your course content and the examination point of view, I have chosen only a few of these semiconductor nanoparticles. But if you want to learn, if you want to involve in the research activities and other things, you are free to refer any research articles. Fortunately, Saturday, Dr. Manmohanlal Satnami has given me large number of photographs, because in his lab he has prepared very good semiconductor nanoparticles, cadmium sulfide, cadmium selenide, as well as the core cell nanoparticles. But unfortunately I am unable to include all those papers due to shortage of the time and some technical problem. But in future I will show you all those very beautiful photographs, although photographs of cadmium sulfide or any things are available in the book, but I want to show you the original photographs taken from our lab, actually that is in chemistry department. But anyway, one important thing I would like to tell you, that when I have searched the literature and the library, I have found there are many books available in our library, even in my lab also. But I found that this is the best book for the examination point of view, or for the student view. And I think only one copy is available in the library. You can issue that book. I don't have this book right now, but I think this is the best book for the student. So nanostructures and nanomaterials. Even in this book you will find the physical properties of the nanoparticles, as well as the metallic synthesis of the metallic nanoparticles, as well as the non-metallic nanoparticles, or like that. As I told you that it is very difficult to classify the total number of semiconductor nanoparticles, but deliberately I have chosen some of the important nanoparticles, of course, semiconductor nanoparticles, which have been used in various fields of the chemistry. So, basically, most common used nanoparticles are second to sixth group, and under this category we will study the cadmium sulfide or CdSe. Zinc sulfide is very important, zinc oxide is also very important, and some third to fifth group is gallium nitride, as I told my last class also, which is very important in nowadays. It is the most important quantum dot nanoparticles, and it is thoroughly used in the optoelectronics and laser, and 2014 a Nobel Prize was awarded for this type of the work. So that is a very important nanoparticles. Now if you ask me that what are the common methods for the synthesis of these nanoparticles, of course quantum dot nanoparticles, method is very simple. Basically, as I told you that I am using the wet chemical methods because we are chemists. I told you many times that we do believe in simple one-step synthesis, and for that a specific glassware assembly is required. Sometimes it is called the hot injection method. And another very important method, if time permits, I will discuss the sol gel method. Basically, most of the oxide type of semiconductor nanoparticles, oxide types of these nanoparticles can be synthesized with the help of the sol gel method. In addition to that, there are solvothermal and hydrothermal methods. But as usual, I am avoiding the green synthesis of the semiconductor nanoparticles. But nowadays, scientists are using green synthesis for the semiconductor nanoparticles. But I am not dealing with this green synthesis. So, one by one I will discuss these things. Now, this is the one of the, you can call it a one-step synthesis. Everywhere we need a precursor because it is like cadmium sulfide or cadmium selenide. So therefore we need two sources of the precursors. One is like that cadmium chloride and H2SC. So there is a direct formation of this quantum dot nanoparticles. Similarly, if you want to prepare the lead sulfide semiconductor nanoparticles, I am taking this lead nitrate and H2S gas. So this is the simplest method and I am taking from this literature. Now I am coming to just little bit difficult types of the things. Now, because you are studying in this chemistry department, and in our department most of the teachers are working on the nanomaterials, and you are all aware of this great man who has got Nobel Prize, Louis Brass. Actually, he synthesized the first semiconductor nanoparticles, I must say. And there are a large number of research papers, even from 2008 also he is publishing large number of nanoparticles, and his papers are very nice. I have just used only one of his papers, and that is Journal of Chemical Physics in 1983. So he actually, I must say, he is the pioneer in the field of this cadmium sulfide or selenium or tellurium nanoparticles. So if you want to learn much about these things, you can go all the research paper of Louis Brother, even Mongi, Bawandi also, because in 2023 Nobel Prize Chemistry for the studies of the quantum dots. Now, as I told you that there are a large number of research papers available, there are a large number of review articles are also available, but again you are all students and you are preparing for the examination, so therefore I have chosen only a few of those type of this, but there are many synthetic methods. So some of my method is based on this review article. Now, as during the study of the metallic nanoparticle, you have seen there are large number of precursors, large number of reducing agent and capping agent or the stabilizer like that. Here is also same thing, that you see, suppose I have to prepare the CDT, and again you see that size is 1 to 10. Some are of course 11.5 like that. This is core cell nanoparticle. But suppose I have to prepare one cadmium sulfide and I want size is 3.8 nanometer. So precursor will be different like that. I will show you that how do we get desired size nanoparticle of less than 5 nanometer. So therefore I need the cadmium acetate and one source from the sulfur from H2S gas, or suppose I want to prepare 5.1 nanometer size, then of course I will take the CdCl2 or any type of the thing. So what I mean to say that depending upon the size, we can change the precursor as well as the stabilizer. But as I told you many times that for studying the semiconductor nanoparticles, there are certain important solvents, which is very important. One of is trioctyl phosphine oxide or like that. Oleic acid is also used. So these are the some solvent which is common for any type of. So, and another point is that here we need the temperature is very high. High means 200 degrees centigrade. But when you see that when you prepare the gallium nitride, temperature will be more than 900 like that. And these three solvents are commonly used. One is, as you know, that trioctyl phosphine oxide like that, and trioctyl phosphine. Same, it is a trioctyl because it is acts as a very good stabilizer. It will bond with that zinc or cadmium or like that. And this is nowadays people are also using this solvent also, tetradecyl phosphonic acid. Then oleic acid is also used. And the principle is just like your metallic nanoparticles. First part is that nucleation, same thing, and then is supersaturation, Ostwald spelling mistake, Ostwald writing, and that side selective precipitation. That is called the Lamer mechanism, how to synthesize this nanoparticle. So these are some anhydrous solvents. Now I am coming to first is that general method for this cadmium sulfide, which is very commonly used. So naturally one is cadmium, another is sulfide. So two precursor, one is dimethyl cadmium dissolved in suppose top solvent, another is we need the sulfide we have taken from the TMS, trimethyl silyl sulfide. So it is dissolved in tofu, and there must be a single injection, hot injection method Of course, inert atmosphere is required to avoid any impurities. So 1 mole of methyl cadmium is added to 15 ml of top anhydrous solvent and 10 ml of 1 m top AC stock solution. Like that means X can be, you can change all these things, and ultimately we increase the temperature, and there is a constant stirring to 5 to 6 hours. Then sometimes after that mixing, we decrease the temperature and then wash with the distilled water and other things, so we can prepare the cadmium sulfide. And 2 solutions are combined and loaded into syringe in the dry box, vigorous stirring as I told you, and then heat is removed from, because we decrease the temperature, and we get very good yellow orange type of solution. Absorption is 440 to 460, and then we gradually raise the temperature. Purification is also required because we have to remove this solvent. Now why I am giving the range? Because it depends upon the types of the precursor. So 1.5 to 11.5. It is a general method. But why I have given some specific 1 ml or 2 ml, I have taken from that method. So you can see this table, and this table I have taken from this review article. And there are some photographs also, but I am not showing you the photographs. Because in the examination, you have to write the equations. Therefore, I am using some of the chemical reaction. That is the things. Otherwise, you will get large number of information about the synthesis. But I am concerned about the equations like that. Sometimes what happened, you see the very simple type of things. After the cadmium sulfide, role of the, now what is the role of that capping agent? So due to nucleation and growth, van der Waals forces can cause quick coalescence and formation of the uncontrolled particles. So to avoid this problem, such type of capping agent TOP, TOP or TOPP, even as I told you, the oleic acid is also very, nowadays people are using the oil because these are very costly and toxic. So because it is a research, so people are trying to substitute this type of anhydrous toxic solvent, costly solvent. So they are using some green solvent like that. But ultimate objective is that to get the size and shape dependent pure semiconductor nanoparticles. That is the objective of any type of synthesis. Now I am coming to another that is also very important, CDT. So it is also very simple. High temperature thermolysis of precursor in coordinating solvents. Again, same solvent. I am not using that type of solvent, long chain alkyl phosphines like TOP and TOPO. But you see, there is a variation in temperature. If I want to prepare CDT, only 100 degree temperature is enough. CD, cadmium perchlorate like things, react with H2P. So again, 2 precursor, one is tellurium, another is this cadmium, so that can be formed. This InCl3, again trimethyl silyl, so this type of quantum dots, but here temperature is very high. Now I am coming to another method, which is I think Dr. Manmohan and other, they are using the simple method. They are not using that dimethyl cadmium, I think. So here size is 8 nanometer. So cadmium acetate as well as the lead acetate, you know. And source of the sulfide is thioacetamide in methanol. And capping agent, there are some surfactants, and there are also 3-amino-propyl trithoxysilane and 3-marcaptopropyl trithoxysilane. It depends upon the nature of the which type of quantum dots you want to prepare. Now, this is a very, very important research paper, and I think this is the one of the simple methods by which one can prepare this with the help of very simple solution. That means, and it is available, this H2S gas and other things, and it is published in Journal of Physical Chemistry 1994. So you can understand that I have such large number of research papers, and out of this large number of research papers, I have chosen the easiest simple method for the student. So this is also very old paper. Now very simple is why I am giving the complete information, because I have gone through this research paper. Otherwise you can directly write a solution of, it is not required to write 5 millimole, or you simply write that you have to take two solutions. One is CdClO4 and another is that thioglycerol in 250 ml of water. For adjusted to pH. Sometimes pH is very important. After this lecture I will show some of the pH dependence and how we control the pH with the help of sodium hydroxide. So I think pH is around 10, like that. And before the addition of H2S gas, you have to control the pH. The particle size was controlled by the quantity of the H2S gas added as well as the temperature and duration of further heating. The sample was prepared by the addition of 25 ml H2S and stirring for 2 hours room temperature, constant stirring, and dialysis for the purification. There are certain type of membrane, so in order to get the purest form. So this is one of the simplest method. We don't need dimethyl cadmium or other things. No topo solution, direct H2S gas and pH control is there. Similarly, why people are using this cadmium selenide semiconductor nanoparticles are the most widely studied system? Because you know, I will show you the one table, they can show you the band gap, band energy. So it is very easy to control the size and shape. So therefore people are using this type of, and I think the first paper, yes, I have taken from this system. This is actually called that single hot injection method. So cadmium sulfide quantum dots are synthesized using the hot injection method, in which the trioctyl phosphine selenide precursor and the shape inducing cationic surfactant are injected into a cadmium oleate containing solvent. Temperature is around 190 or 200. So you have seen that temperature range is 100 to 200, like that. So this is injection syringe and there is a hot solvent. This is digital thermometer. Organ outlet, as I told you, that inert atmosphere is required, and I have taken from this. Again, I have written the equation. So it is cadmium, of course, topo solvent, selenium top solvent, and so it is called the hot injection methods, and it is a very common method, and most of the laboratory they are using that hot injection. So therefore I have given only one photograph from, of course, from that literature, and it is a very good journal like Science Journal. I have taken from these photographs. Now this is the, again, as I told you, that credit goes to this research paper, because as far as my knowledge is concerned, that this is the first paper related to the formation of that zinc selenium, and this is published in Journal of Physics. I have tried to see in this paper, but I have only received the abstract, and from the abstract I have prepared these things. So I think zinc, dimethyl zinc, and again it is a solvent related to the selenium, and this type of solution is formed. And then you have to add one stabilizer, hexadecylamine. Temperature is 270 degrees centigrade. So this is two-step mechanism, but this is one of the why this method is important, because this is the first paper by which one can synthesize this zinc selenium compound. Zinc sulfide is also very important, but it is also not at all very difficult to prepare. To obtain zinc sulfide nanoparticles, any zinc salt like zinc sulfate, zinc chloride, zinc nitrate or zinc acetate can be dissolved in aqueous medium, and Na2S is added to the solution. One even dissolve the H2S gas. That is the very simple method. Now the last part, as I told you many times, that you must prepare a short notes on this gallium nitride. There is a possibility of short answer type of the question, that what is the importance of gallium nitride, what are its application, and what is its band gap. You see 3.4 electron volt, and it is high heat capacity and thermal conductivity, very stable, very stable, and it is useful for sensors and high power electronic device, and it is a promising light emitting materials. And you are all aware of this Nobel Prize about this role of gallium nitride and the application of blue emission light. It is very important, and so therefore, and fortunately there are at least 10 to 15 methods, but I am using very simple method. But it is up to you. You can use any type of any method. So very first method is simple. The reaction with some gallium salt with a ammonia, and there is a production. Why it is important? Because with this nowadays everybody is talking about the hydrogen, production of the hydrogen or the green hydrogen and these things. So, but you know the problem is that the temperature. So, but now methods are available where we can use these other techniques where temperature is not so high, 900 to 980 like that. Green synthesis is like that. But here gallium nitride can also be synthesized by injecting ammonia gas into molten gallium at very high temperature at normal atmosphere. This is a very old method. People are not using this method. I am coming to some new method that is called the sustainable method, because it has got tremendous application in industry, in optical industry, optoelectronics industry, sensor. So now again it is also not very new paper, 2015. So I have taken this method from this review article, synthesis and characterization of gallium nitride nanoparticles by using solvothermal soft chemical methodology, and there are many methods. So gallium nitride was prepared by solvothermic route using gallium acetyl acetate and ammonium acetate as precursor in a stoichiometric relation. In addition, in this work, different compounds like ethanol, ethyl glycol, propanol and benzene were used as a solvent. Now if I want to see the latest method, of course here size is very high. So what is the challenge for that method? Every method, one is the temperature. But you see, but there is a problem. We are not getting very, size is very high. Temperature is good, but size is not up to the mark. But it is a simple method. reaction between lithium nitride and gallium chloride in a benzene autoclave. We have an autoclave in our lab, so in autoclave we can use this, but of course we can get the gallium nitride, but the size is 30 nanometer. Now, so I have covered the cadmium sulfide, cadmium selenide, cadmium telluride, zinc sulfide. Now the second type of, today I will not discuss about the ceramics and other things, but I will only discuss the sol gel method. So oxide nanoparticles are very simple, but synthesis are more difficult, and theory is exactly same. Like first is there is a homogeneous nucleation, again then growth and Ostwald ripening, same thing. But there are some simple methods, but most common method I will explain, that is called the sol gel method. And you have to study not only zinc oxide but titanium oxide also, titanium oxide, silicon oxide. So most of this oxide type of semiconductor nanoparticles have been used as a photocatalyst. Most of the, like zinc oxide, titanium dioxide, tin oxide, copper oxide, iron oxide. Some of these iron oxide nanoparticles are magnetic type of the things. So I will discuss one or two methods, and then I will discuss the sol gel method. So here is also we need the precursor, same thing. And this is the simplest method. First I am using the simplest method, and then of course some complicated method. Not complicated, but that is the sol gel method. So first point of that sol gel method is that there is a process of hydrolysis followed by the condensation or the polymerization and something. But everywhere we need some catalyst for acid and base in order to get the correct form of this type of thing. So suppose you want to prepare the silicon oxide, silicon dioxide, like that, silicon, so SiO4, some alkoxide type of things, react with alcohol, ammonia, then water, it will form the such type of things. This is also very important. Why? Because sometimes some of the semiconductor nanoparticles are showing some magnetic properties. So FeCl2 and FeCl3, ammonium hydroxide and the dextron, so will form the Fe3O4. Now suppose I want to prepare the zinc oxide nanoparticles. Again I am taking this method, and you realize that everywhere I am using the equations. So that is my objective, that because we are chemists, many times I am told you several times that we are chemists, so we are interested in the chemical methods and bottom up method, not the top down method, lithographs and other things. So therefore my concentration on the chemical reactions. So therefore I have searched the literature, and then this is also a very good research paper, the Nano Express, synthesis of zinc oxide nanoparticles by two different methods, comparison of their structural, antibacterial, photocatalytic and optical properties. So don't worry about the properties and the application. So you see that zinc acetate, very simple method, was mixed with 150 ml distilled water and steamed for 20 minutes at 35 degrees. Very low temperature is there. Again, why we are using the sodium hydroxide? Just to maintain the pH and other things. So after mixing both solution, the titration reaction was performed by the addition of 100 ml ethanol for the vigorous steaming. So ethanol or surfactant, they are acts as a capping agent or the stabilizer. This is the simple reactions. So oxide nanoparticle oxide nanoparticle can be synthesized with the help of sol gel method. It is very simple method, and most of the oxides can be synthesized with the help of the sol gel method. Here we can perform the experiment in a normal temperature, and purity will not be a problem, and it is very simple method. So just I am giving one example of the sol gel method. So it is general method. For that, we have taken a metal alkoxide. There are two steps. One is called hydrolysis. So first part is hydrolysis and second part is condensation. Or you can call it polymerization. So sol gel method, oxide synthesis, hydrolysis and condensation. So I am giving one. Sol gel method. So I am taking one metal alkoxide. It can be metal ethoxide or methoxide, so okay. So it is metal alkoxide hydrolysis process. X, suppose hydrolysis is water. So you know that hydrolysis means the H and OH. So first part is that M O P T 4 minus X, and this OH is plus ETOH X. Sometimes the hydrolysis process is very slow. Then what we do, we can use some of the Suppose the hydrolysis is very slow, so we can use some acid or base. Just they use as a catalyst. Now first part is the hydrolysis, second part is very simple, it is a condensation. So what we do, just M O E T 4 minus X OH is combined with another molecule M O E T 4 minus X. So now the M O metal oxide. So just if I write like that, so it will form O E T or minus X OH X minus 1, and now this M this M this O M and rest thing is like that. X minus 1. So this is actually called the metal oxide bond and the sol gel method. And then as per your requirement, you can evaporate it. So different types of gels can be produced. Thank you very much.